Okay, so in today's class, we will start differentiation, that is of Pure Maths 1 Edexcel. Okay, and I will start with power rule directly so that we can understand the main important part of differentiation first, and then I will, in the later classes, I will explain principle of differentiation by first principle. Okay. Great. By the way, differentiation is a very easy topic once you understand it, and most important topic as well. Because once you understand differentiation, like if you are good in differentiating any function, then we have to learn in Pure Maths 2 and Pure Maths 3 applications of differentiation. And those things are quite, you will find helpful if you are okay with differentiation. So let me try to make it most easiest topic for you, differentiating. Okay, so we will start here. We will start with differentiating x raised to n. Let us say anything that is in the form of x raised to n, like if I write x raised to 5, x raised to 6, like these things. How to differentiate such things? So differentiating x raised to n, where this n is a constant. Okay, anything, this x is a constant. So we have rule 1, and rule 1 is called as power rule. uh, Power rule. Why power rule? Because we use rule 1 to differentiate anything that is in the power. So x raised to n, differentiation of d upon dx of, here I have written d upon dx of x raised to n. First, this d upon dx, we apply always. D upon dx, we read it as, like here I have written how to read it. We read it as, a differentiation of x raised to n. Different d upon dx, we will simply, for now, we will simply say it a differentiation. So differentiation of x raised to n is, the formula says, differentiation of x raised to n is this power jump off. Like now, n is in the power, so this power will jump off and n will come here, and then the power, since it jumped off, so its power will decrease by 1. है ना? After jumping, definitely your power decreases, so your power will decrease by 1. So differentiation of x raised to n is n into x raised to n minus 1. We have to remember this. This is the first rule or first formula, you can say. Okay. Again, I am saying differentiation of d upon dx is called differentiation of x raised to n equals to n into x raised to n minus 1. Okay, so this is now differentiation of x raised to n is n into x raised to n minus 1. Is it done? Let us do quickly these examples. If I ask, can you give me d upon dx, differentiation of x raised to 5, what will be then the result? Yes, so 5 will jump off, and x raised to, and power will subtract by 1. So 5 into x raised to 4. One more, please. D upon dx of x cube, x square. Let us do x square. So x raised to n is n into x raised to n minus 1. This power jump off, and the power will decrease by 1. So 2 minus 1, this is 1. And it is 2x only. Okay, great. And we use, in differentiation, we use some notations, and those notations we say at, like a differentiation of f of x. Sometimes our function, the function that we have to differentiate, sometimes the function is given as f of x, and in that case, differentiation of f of x is represented as f dash x. Okay, f dash x. Here this dash means ki you have differentiated function f of x. Okay, and one more notation we have to understand, differentiation of y, always differentiation of y we will call as dy by dx. Okay, so these two notations we have to use. Let us see the second rule that we have. Second rule is differentiation of k into x raised to n. Anyway, sometime if we have differentiation of any constant, differentiation of a constant into x raised to n, so this constant remain as it is, and you differentiate x raised to n, and we know what is the differentiation of x raised to n into x raised to n minus 1. Okay, so this k and n, this k and n gets multiplied, and the power of x decreases by 1. Okay, So basically what we understood, differentiation of k into x raised to n, I will keep k as it is and simply differentiate x raised to n. Okay, constant k into x raised to n, you will keep constant k as it is, and a differentiation of x raised to n is x raised to n minus 1. Let us do one example based on this also, and that is d upon dx of, let me try whether you can solve it. Differentiation of 5 into x raised to 3. Is it in this form, k into x raised to n? Yes, here k is a constant. Okay, so what we learned, 5 will remain as it is, the constant remain as it is, and we differentiate x cube. Differentiation of x cube is 3x square, correct? The power jumped off and the power decreased by 1. And in the next step, 5 into 3, 15x square. So simply, can I say this way, let us multiply this two, 5 3 are 15, and then decrease the power by 1. Shortcut is this one. Let us do a few questions based on this. Okay, so here these are my questions. Yeah, by the way, I take examples only because example covers almost all conceptual questions, all variety of questions. Mostly through example we get covered. Yes, so let's try to this. Find the derivative. Find the derivative f dash x. Please see, they have written find the derivative f dash x. Okay, when f of x. So I am. Let us start solving a. Here f of x is how much? F of x is x raised to 6. Yeah. Now, if I differentiate, and when I will differentiate, we differentiate both the sides only. What? Let us differentiate both the sides. So what we are doing, differentiation of both sides. So differentiation of f of x, I think just now in notations we have learned differentiation of f of x, we write f dash x. Okay, and equals to x raised to 6. Is it in the form of x raised to n? X raised to n, where n is any constant. Yeah, we use power rule to differentiate it. The power jump off and decreases by 1. So it is 6 into x raised to 5. I think we have our differentiation. Let's do part B. In part B, our f of x is how much? F of x is x into, yes, x into x raised to 1 by 2. Yes. And simply what we know, x raised to 1 by 2, it is nothing but root x. Okay, x raised to 1 by 2 is nothing but root x. We know root x is only written as x raised to half. Okay, let us differentiate. So differentiation of f of x will be f dash x, and we know is it x raised to half, mean is it in the form of x raised to n? Yes, the power is in constant. Yeah, so let us use power rule. And what is power rule? The power jump off and decreases by 1. So this is half into x raised to half minus 1. Okay, half. And if I solve it, I will get it as half into x raised to minus half. Okay, and that is equals to what? If I solve it further, I will get it as 1 upon 2 into, see, x raised to minus half. If I try to make this power positive, we know in indices we'll learn this. Uh, if you want to make your power positive, you have to shift it from numerator to denominator or denominator to numerator. Right now my term, the whole term is in numerator, so I will make it in the denominator, then my power becomes positive. By the way, our answer, we have our answer right now here, but let us try to simplify it as much as possible. So it is 1 by it x raised to 1 by 2, and in the next step, can I write this is nothing but 1 upon 2 into x raised to half, as I want to write it as root x, correct? So here what we, I think our differentiation is quite done. Mostly we are done with differentiation, but here we have one very important differentiation. See here, the function was root x, and what is the differentiation? 1 upon 2 root x. So let us write, this is most important because we use this differentiation a lot of times. So I will suggest you to note it, or if you can remember it. So what we got here, we got a differentiation of, can I write this way? D upon dx of root x is differentiation of root x. What we got? 1 upon 2 root x. 1 upon 2 root x. I will suggest you to remember, because we will use this differentiation of root x a lot of times. Okay, let us take the C part. C part is my f of x is how much? My f of x is nothing but x raised to minus 2, and let us differentiate. So f dash x, differentiation of f of x is nothing but f dash x, and I think here right hand side we will apply power rule. So minus 2 will jump off and x raised to minus 2 minus 1, that is minus 3. Yeah, we have our differentiation. We have our differentiation right now. Again, you can write it, make the power positive. So it will be minus 2 upon x cube if you want. Let us take the part D. This is quite simple. By the way, part D is quite simple as a way. So here my function is nothing but x square into x cube. Yeah, and what we can do, we can add this to power. In indices only we learn that base are same and there is product. See, the base is here x, the base is here x, and you have product. So you add the power. So can I write this way? My function f of x is nothing but x to the power 2 plus 3, that is 5. And now it is very simple question. Let us differentiate now. Differentiation of f of x will be f dash x, and differentiation of x raised to 5. Can you try? It is 5 into x raised to 4. Yeah. So I think we have our differentiation. Let us do part E also. In part E, my function f of x is nothing but x upon x raised to 5. Here also, first we will simplify it and then we will differentiate. So the base of numerator is x, the base of denominator is x, and there is division. So as per indices rule, if you have same basis and there is division, you subtract the power. So can I write this way? My f of x is nothing but x to the power, here it is, my power is 1 and here it is power 5. So 1 minus 5, 1 minus 5, 1 minus 5 is minus 4. Yeah, this is equals to, this is nothing but x raised to minus 4. Yes. And now can you differentiate? Yes, let us differentiate. Differentiation of f of x will be f dash x, and that is equals to minus 4 into x raised to minus 4 minus 1, that is minus 5. We are done with our differentiation. Yes, let us take one more type. Okay, here as rule 2, what we learned here as rule 2, differentiation of k into, okay, so as rule 2, we have learned it. Differentiation of k into x raised to n is, we keep constant as it is and we differentiate x raised to n. So k into n into, we differentiate x raised to n. Let us take questions based on it. So yes, this time they have find dy by dx when y equals to this time. Okay, so if I write part A, my y, this is y equals to 7x cube. Okay, let us differentiate both the sides. Differentiation of y is dy by dx. Yes, what we learned, differentiation of y is dy by dx, and that is equals to, in the right hand side, is it in the form of k into x raised to n? 7 is a constant, correct? So what we do, we keep constant as it is, and differentiation of x cube will be 3x square. And in the next step, this is nothing but 7 into 3, you will multiply it 21x square. Yeah. Simply the shortcut is multiply these two numbers and subtract the power that way. Let us do the part B, that is here my y is minus 4 into x raised to half, x raised to half. Yeah. Uh, I will simplify it first. Minus 4 into, I will write x raised to half as root x only. Okay. And now let us differentiate. Differentiation of y is nothing but dy by dx. And we know this is k into minus 4 is a constant. So any constant is multiplied with some function. K into root x. So I will keep my constant as it is, and differentiation of root x. Here we have noted it. See, for just now it came. What we learned, differentiation of root x is 1 upon 2 root x. Although we have derived it, but as a rule also, as a property also, if you remember it, our process will be fast. So what about differentiation of root x? It is nothing but 1 upon 2 root x. So finally my answer is, and this 2 and this 2 will get cancelled. So this 2 and this 2 will get cancelled. So I am left with minus 2 upon root x. Okay. So here, this is my question, by the way. Yeah. Let us do part C. In part C, my question is, by the way, part C is quite simple. Let us not do it. Part D is also quite simple. Let us do part D. Part D, what about part D? Part D is my y is nothing but, yes, let us write 8 by 8. Okay. The question is 8x raised to 7 upon 3x. Yes. Can I write this way? Y equals to, let us write constant separately. So 8 by 3 into, and then this is x sub raised to 7 upon x. And I think we can simplify it. X raised to 7 minus 1, that is x raised to 6, as per the indices rule. And now let us differentiate. So my differentiation is dy by dx is dy by dx. Differentiation of y is dy by dx. I will keep my constant as it is, and x raised to 6 is 6 into x raised to 5. And now if you simplify it, 3 2 just 6, so it is nothing but what we got, our dy by dx is, what we got, our dy by dx as 8 2 just 16 into x raised to 5. Okay, let us do the last part also, that is e. That seems quite a good question. So if you, so my y is nothing but root of 36 into x cube. Yes, this we will simplify it first. So if you have product inside the root, you can separate the root. Like I can write root of 36 into root of x cube, and this is equals to y equals to root 36 is nothing but 6, and this is x cube whole raised to power half. What I have written? I have done square root as a power half, and we know there is 3x to the power 3 to the power 1 by 2. So as per indices rule, this power gets multiplied. So it will be 3 by 2. So I will be left with y equals to 6 into x raised to 3 by 2. Yes, let us differentiate now. So if I differentiate my dy by dx, can I do here now? My dy by dx, let me solve. After this, I am solving here. Yes. So my dy by dx, dy by dx equals to 6 is a constant. Right now my RHS is in the form of k into some x raised to n. So 6 will be here only, and then differentiation of x raised to 3 by 2. I think we know the power jump off and it decreases by 1. 3 by 2 is 1.5. 3 by 2 is nothing but 1.5, and 1.5 minus 1 is 0.5, that is half. So I will write it as half only. Okay, and now this 2 and 6 we can cancel. So my final answer is, my dy by dx is, my final dy by dx is 6 3s are 18 into x raised to half, and let us write x raised to half as root x. So did we got our dy by dx? Yes. Okay, let us write this is equals to 8 to just 16 x raised to 5. Yeah, that's it. Okay. So this was about power rule of differentiation, most important most important property about differentiation. So I think what we learned here, if I have x raised to n, we will do n into x raised to n minus 1. That is the power jump off and it decreases by 1. And rule 2 we learned, as in rule 2 what we learned here, some constant k into x raised to n is nothing but you keep constant as it is, and then n into x raised to n minus 1. Okay, so it was about it. If you are liking this discussion, the explanation, please consider like and subscribing to the channel. Thank you.